Hello students, welcome to my YouTube channel Data Guru Akash. And in this video, we are going to talk about the pre-processing process. See, this is what the last thing that we had seen, the data science pipeline. So we had seen the data mining, data pre-processing and EDA. So we will see what are there in this. So basically we'll be looking into this ML and evaluation later. So as of now, I'll just give you a glimpse of what exactly we do the pre-processing and in exploratory data analysis, right? So let's see, once you have got the data is not always ready to use. Sometimes you will see some null values in the data, right? So what you have to do, you have two ways, right? So first, the one way is that you can simply delete those rows, right? Or you can simply delete those columns. If one particular column has a lot of null values, let's say you have x1, x2, x3, these are the columns. Y1 is the y is the corresponding output column. See, always I'll be referring input columns as x1 as x and input output column as y or label column as y. Remember that this particular question might have cleared, right? So if we have data is nothing but the combination of the input data and output data, right? In this particular thing you might have seen, right? Result and the data. Result is nothing but the output data, right? So in this case, if you see, we have x1, x2, x3 as an input values, and y1 y is the output in this case. So sometimes you will see, let's say this whole thing has 5,000 rows, right? This whole thing has 5,000 rows, so that means 5,000 number of data points we have. For each data point we have total 3 column and one corresponding output. So for example, let's see, this is the data set of the fruits, right? So let's say there are total 5,000 fruit data set, in which there are some some apple or might be there, some oranges might be there, and some bananas might be there. Right? So that might be the data. And in, let's say, in x1 feature we have shape, size, and let's say shape, color, and this one is let's say shape, color, and this one is what we can see shape, color, and this one can be color and weight, right? So, and this one is, let's say, apple, oranges, and banana, right? So that's the output. Okay. So let's say this color variable, right? Color variable out of 500, let's say 400 are null, means there are no values in 400 data points. It's null, simply empty, right? So what will you do of this particular feature? You have only 1000 value, right? That too is you will not be able to use appropriately. So it's better to drop this particular column, right? So we do not do this in this case. So if, let's say, large portion of the data is more than 50% of the data is empty, then you can simply drop that particular column. Okay. Now let's say not 4,000, let's say only 1,000 or 500 or 50, 60, some things are empty, right? Then what you have to do, if you think, let's say, your data set is enough to make the learning process happen, then you can simply delete those particular data points only. So let's say if this column has, let's say I would say okay, so let's miniaturize this. Let's say we have total 10 rows, and in let's say this one has this one value is empty in this case, right? Let's say here these are the values, and this means empty. Right, so 1 2 3 4 empty. Like that, right? So you see, this is straight line means empty data, and this particular means that we have a data. So you see here we have some missing data, here we have some missing data, right? So for this particular instance, for this particular fruit, we don't have the shape feature. For this particular fruit, we don't have the color, what color it is. For this particular fruit, we don't have the weight, right? So what can we do in this case? Now you can think, let's say your data size is very, very large, right? Here I am taking 10 examples, but let's say your data size is very, very large. Let's say 50,000 data points. And in out of these 50,000 data points, if you have, let's say 100 or 200 or 500 data points are like this, right? So somewhere one of the shape is missing, one of the feature is missing, that is empty, then it's very, very convenient. You can simply drop those drop those rows, not particular column, right? Because you see in each column, you have at least 1, 2, or, at least 100, missing values will be there. So you'll not be simply dropping the column, you'll be dropping the row, right? You'll be dropping the row. So intelligently you have to select whether you have to drop only the rows most of the time. The column will be dropped only if you have like more than 50% of the data is empty, more than 50% or 60-70% of the data is null. So in that case only you can simply drop the rows, drop the column. Otherwise you only have to drop the rows. Dropping is not only the solution in this case, you can simply fill those values as well, right? So for example, so do you understand the shape of the data? We have this three inputs and one particular output in this case. So you'll be dropping the column only if you have more than 50% of the data into that. This is my assumption, more than 50%. Like you might set your own rules as more than 60% or more than 40% itself. You can, so basically when you work along a lot of problems is the same way, so you'll be able to find the particular solution for that particular problem. Okay, you can set your own parameter, you can set your own standards on the problem. So then you will be deleting the column. Okay, if you have in that particular column, if you have more than 50% of the data is empty, null, then you can delete that column. You have to delete the rows if do not have right, if you have a few data points missing, right? So you cannot proceed without with having the null values in the data. You will have to either replace them with some value, or you can simply delete those data points, right? Deleting the data points will not affect in the quality of the data. Basically it will improve the quality because you have removed the null values. Okay, but sometimes we do not have that much data points to start with. Right, so for example, here we had 50,000 data points, and out of them we have total 500 null values in different columns, right? So in this case, if you delete them, so we'll have let's say 49,500 values. So 500 data points. This is enough, right, to make learning process happen. And if you see the percentage term, only I think 1% of the data is unavailable, right? So you can simply delete those columns. Okay, 5,000 data points means 5,000 rows. See, data points and features. Features means column, data points means rows. Okay, data points means rows means what? You are taking one feature from one instance, right? Data points are instance. One instance or one data point, I would say that is nothing but one row, one particular data point. For example, if I take a fruit, if I take let's say an apple, so what is it? It has a shape. You will be able to see what shape it is. You will be able to see its color. You will be able to see its weight. So this particular thing is nothing but one data point for you, right? If you take another apple, that will be another data point. You are logging their information in each row. That's what it is. Features we say, or let's say sometimes we call it columns or features. And if let's say you have very less data points to start with, okay, very less data points to start with, then what will you do? For example, let's say you have only 5,000 data points, or not only 5,000, let's say you have 1,000 data points. And out of this 1,000, if you have, let's say, 300 data points are missing. So 300 is a very, very, huge amount, right? And if you're going to see, let's say 300 means, let's say some is missing here, some is missing here, some is missing here. And if you're going to delete, see, if you're going to delete this, so what will happen? Let's say you have one missing value here, one missing value here, one missing value here, and one missing value here. So if you're deleting, so you will have to delete this whole row, right? Here, although you have data and here missing value, but you cannot just delete this. It will corrupt the data. Integrity of the data will not be maintained. So for example, if you delete this, right, so what will you fill in here? Once again, it's null value. Or let's say if you fill the other ones here, so that will be the value from other fruits, not from this particular fruit, right? For example, let's say for apple, you have shape, size, right? And talking about weight, but weight was not there, so you put the weight of banana. That's not something right? So that's you have not to do. If you're deleting the row, you have to delete. If you have, let's say, a data point and you got to do delete it, so you'll have to delete the whole row, the whole data point, the whole row. So if you delete here, so you'll see total 4 rows you'll have to delete in this case. So that's what I say when you say deleting the row and deleting the column, you already know. So let's say in this case, if there are 300 different null values, and then if you are going to remove 300, so you are left with only 700 data points, right? That's actually not appropriate. You are deleting huge number of data points in this case, like 30% of the data you are deleting it. That's not a good thing. So what you can do in this case, you can simply have, fill those values, right? Now, how are you going to fill those values? So can anyone explain me? Let's say if we have some features like x1, x2, x3, where we are calling x1 as, let's say, shape, color, right? And let's say this weight, right? If I have a missing value in, let's say, color, right? How will I fill it? How can I take average of colors? The value that is frequently occurring into that particular column. And if you calculate the probability of that being there in that particular column will be the highest, right? So we can simply impute that by the mean or by the mod of that particular column. If it is categorical, you can go with the mod. If it is numerical, you can go with the mean, right? So for example, if weight is not available, so you can fill the weight of the mean weight of this particular column at every null value in this particular column. That's how you can impute. So you can write it down if you're writing some notes, right? So for categorical column, you have to impute with the mean value, mod value. Mod means frequently occurring value, the value that occurs the most frequently and most of the time. And if it is numerical column, then you can go with the mod, okay? Mean or the average, right? That's not the only one way. For example, let's say here you have apple, right? And here some color is there. And if there is a missing value in this weight column, then the other intelligent way is to fill it by taking the average weight of apples only. You can use median as well, okay? But let's say if there is a null value in this particular row where the colors is red, right? Where the colors is red. So you can simply impute this. You just take the mean of only those values where the color is red, right? If let's say there is a mean value, there is a missing value here, but the color is yellow. So you'll not be filling it with the red color mean value. You will be filling it with the yellow color mean value, right? So that's the way you can do it. So you are using some of the other column that is available to fill the values, right? Intelligently. You can use any other column as well. And not only one column, you can also combine one of the other, 2 columns or 3 columns as well. It's up to you. But if you include more columns, if you are including 0 column, then take the mean of the whole column and then impute everywhere the same value. If you are taking one column, then you'll have to, it will be a little bit complex. And if you're taking 2 columns, it will be more complex, right? So you have to decide what you are going to do, but the quality will be, definitely better than if you're using 1 column or 2 column or 3 column, then the quality will be there. So I will also show you the same thing in the real life data as well when I will work on the real life data, and I'll show you that as well how you can do that. Coming to the other thing, let's say sometimes what happens, for example, that's what we have. Let's say we have color column, right? We have color, let's say yellow, we have red, we have green, right? We have red, green, yellow. Not only this, there might be some other color as well. The models just take numerical input. They do not take these strings, right? If you have a value in an array like this, so these yellow, red, and green, this will be stored as a string, right? So these things will be stored as a string. You cannot pass these string inputs to a lot of statistical models, right? Like you cannot pass this to SVM, you cannot pass this to logistic regression, you cannot pass this to KNN. You have to change these values into numbers. Remember, I told you there are 2 things. First is the categorical values. So the other one is the numerical categories. So you have to change this into numerical categories, right? You have to change this into numerical category. Now, how we are going to do this? So first thing, we'll have to change this into numerical categories by something called label encoding. So these are nothing but the labels. So not only these columns, any categorical column, if you will have to encode them into number, right? So how does this happen, this label encoding? So you can give any number to this yellow, any number to this green, and any number to this red, and replace those by their numbers, their corresponding numbers. Like you can give them like 0, 1, 2. So wherever you see yellow, you will call it 0. Wherever you see red, you will replace it by 2. Wherever you see green, you will replace it by 1. That's it. So that's how you transform your data from numerical, from string categories to numerical categories, and it does not have any loss of information, right? It is just you are transferring one type data, so you have the log of it, right? What is the corresponding? So you can simply make a dictionary. Basically the label encoder object itself saves the dictionary itself. So you can have like what should be the key, right? The key value in the dictionary. So let's say the key will be 0 corresponding to yellow, and the green will be corresponding to 1, and for 2 it will be red. So you know which value is corresponding to which particular color, right? So it's 0% loss of information in this case. So label encoding, you can do this way. And as I said, you can give any value to this, right? You can give any value. It's not like always you will be giving it 2 only, 1 only, right? You can give it, let's say 9, you can give it 7, you can give it 101, anything. If you are hard coding it from yourself, you can give any values, but it is very, very good practice to start from 0 and give 1, 0, 0, 1, 2, 3. If there are more categories, then you can just increase like 4, 5, 6, 7, and 9. Okay, so that's the way you do it. So this is one of the other pre-processing that you do in the data science pipeline. So these are the pretty mandatory things that you have to do this. If you have null values, so you have to deal with the null values. So first thing, if you have these numerical categories like string categories, you'll have to do label encoding. There's one thing that you need to do is normalization. And you know what, you also have to label encode your output as well. For example, you have apple, oranges, and banana, right? So you also have to label encode them, right? Let's say you are encoding it to 0, 1, 2, and then after after doing the prediction, if the model is predicting 1, that means it is predicting orange. So you can change them later on. Okay, it's not a big deal. Okay, so that's the label encoding and decoding. Label encoding and decoding. So normalization means, so there is another step that you have to do, that is normalization. Thank you so much for watching this video. If you liked it, do press the like button and subscribe the channel for future updates. Also hype the video so that it can reach more students and they can also get benefited from it. Thank you so much for watching this video. We'll see you again in the next one. Till then, bye bye and have a great day.